This is Brent with Lykins Motorsports, and we are working on one of the 428s that I have going on, and I have two pretty much of very similar flavor 428s being built. I've had pistons on order since April, and they've been telling me for weeks that I would get the other set first, but it turned out I got this set first, so it wasn't the order that I was planning on doing it, but you kind of work with what you get at the time. So this is a period correct 428 build for a Shelby Cobra replica, and I've started some videos on this weeks ago, and I had to send the crankshaft out because the bearing clearances were too tight. That has been corrected, and I've already bore mic'd my main bearing housing, and we got the bearing clearances in check around 2.5 thousandths to 3 thousandths. So we're in the money there. This is a Scat 398 stroke crank. It's brand spanking new. It has been internally balanced, as you can see, with the two little pieces of heavy metal there. So you do not have to use a counterweighted flex plate or flywheel. It takes an internally balanced flex plate or flywheel. So the crank is in, and had all of our bearing shells lubed up. We've got a rear main seal in, and the seal is facing towards the front, as it should be. One thing that I've already corrected, and you need to check when you lay the crank in the block, you need to go ahead and check your crankshaft thrust clearance or your in play. It's a good time to check it. Sometimes I've ran into situations, and this is one of those situations where I had to sand the thrust surface of the bearing to gain the clearance. I only had 3 thousandths when I started, and now I am up around, I think, 7. So you check it with the upper half in there, and then you check it again with the cap in there. And sometimes you have to adjust one, sometimes you have to adjust both, but something you need to check. So we have the crank in here, and I want to start putting the main caps on now. Okay, main caps are on. Everything spins real nicely. Just going to go ahead and put our silicone in for our side seals, get our timing set on there, and then start to degree the cam. This is going to be a fairly long video. I'm going to try to knock out the entire assembly, so I probably won't show a lot of little details, but just kind of hit the main points as we go. All right, so let's go over some camshaft degreeing things, and I've shown some degreeing techniques in the past in some of the videos, and you know, it's kind of one way to see it with the lifter in and the dial indicator and all that stuff on there, and it's another to see what's actually happening. And the reason we degree camshafts is, for one, you want to make sure that the cam is ground the way that you told them to grind it, and two, you want to make sure that you know, your crankshaft is correct, your timing set is correct. And, you know, there's manufacturing tolerances to all that stuff. So the cam may be, you know, dead nuts on, but maybe your crank, you know, is a little bit off, or maybe your timing set is a little bit off. So, you know, when I send a custom order in, I'll give them the intake center line that I want the camshaft ground on. So if it's a 113 lobe separation, this one's ground with 5 degrees of advance on it. So, you know, we put the cam in and we check it and make sure that everything, you know, it's just like everything else in engine building. You check it and make sure that it's the way that it's supposed to be. So when we do the degreeing process, well, let's take a step back and just say, you know, the intake center line plays a big role in how the engine performs. And I know there's a lot of generalities about advancing gives you low end power and retarding gives you higher end power. but I've kind of found that it varies from engine to engine and application to application. You know, for instance, an engine builder buddy of mine runs super stock small block Mopar, and his camshaft is ground on a 106 lobe separation, but the intake center line is 98 degrees, and that's where the engine made peak horsepower for that application. So, you know, advancing a lot is not necessarily bad. Retarding a lot is not necessarily bad. You just have to find your sweet spot for the combination that you're working on. So let's look at the lobes on the camshaft. I think I should have taken more time to verify this, but I think the front lobe is #1 exhaust on this FE cam. This would be #1 intake. So, you know, using the intake center line method, what we were doing is we were finding the high point of this intake lobe, and we were moving it back and forth in relation to the crankshaft. So, you know, we can move the camshaft ahead and it would be advanced. We can move the camshaft behind and it would be retarded. And we degree the camshaft to find out exactly where it is. And what we're doing, if you go back and look at my videos, the way I typically do it is I start out on the heel of the lobe, the baseline, the base circle, and I'll set my dial indicator to 0. And the first thing that I do is roll the engine over and get to the highest lift point. And, you know, I watch it on my dial indicator, and then I will compare that number to what it should have been. So the camshaft that I used for this 428 should have been a 353 lobe lift, and it came in at 353 and a half. Splitting hairs definitely there. And then when I get to there, I will zero my dial indicator again, and then I'll roll back a certain amount, usually about 100 thousandths, and then we'll go back to normal rotation, 50 thousandths, and we'll take that number, and then we'll roll through, and we'll go to the highest point on the lobe end, and then start down the other side, 50 thousandths. And basically you're averaging those 2 points to find where exactly that intake center line is. And then I'll go through and do it for the exhaust lobe on that cylinder, and do the whole thing over, measure the lobe lift, you know, find the exhaust center line. And then when I have those two center lines, the intake center line, exhaust center line, I can add those together, divide by 2, and that'll give me an LSA number. And then that'll let me, you know, determine if I need to retard or advance the cam to get it to spec. So the other method is called the valve event method. And if you look at their cam cards, you know, it'll have a specific valve events and at what degree that valve event happens. So for instance, intake valve is going to open 5 degrees before top dead center, and it closes 41 degrees after bottom dead center. Your exhaust valve opens 56 degrees before bottom dead center, and it closes 1 degree after top dead center. So using the valve event method, if I look at this intake lobe again, I can get to the heel of the lobe, set my dial indicator to 0, and I'll go in normal engine rotation. And when the valve starts to open 50 thousandths, then I'll look at my degree wheel and I'll see if that number compares to the number on the cam card. And then we can cross the highest point of the lobe and then come back down the other side. And when the valve is 50 thousandths from being all the way shut, then I can also look at that valve event on the cam card and compare the numbers and then see what needs to be adjusted. So the reason that you have two different methods of degreeing is because some camshafts have symmetrical lobes. So if you had a computer that was, really accurate, or you could see the shape of the lobe really accurately, a symmetrical lobe would be the same shape on either side. An asymmetrical lobe is going to have different ramps on each side of the highest point of the lobe. So in some instances, it may be better to use the intake centerline method. In some other instances, it may be better to use the valve event method. So let's look through what we were able to find out using the two different methods. Using the intake centerline method on this cam, I came up with a 106.75 intake centerline and a 118 exhaust centerline. That gave me an LSA number of 112.38. But if you look and see what results I got with the valve event method, look at the differences here. Exhaust valve opening event, 56.5. We were half a degree off. Closing method, the exhaust valve closing event, 1. So, it's dead on there. Intake valve opening, 5.5. Again, half a degree off. Intake valve closing, 40.5. Again, half a degree off. So, it's worthwhile to use both methods and check it out, especially if you know the particular shape of the lobe you're using, if you have that information beforehand. Because, look at the differences here. I would be almost tempted to make a change here to get to 108. Although trying to, nail a degree and a quarter is kind of splitting it. But, I was very pleased with how this camshaft came in. It degreed in great. And, sometimes we only see a viewpoint from one direction, and another time, it's helpful to see what's actually happening, what you're actually measuring. And all right, so here's our piston to valve clearance check. This was with no head gasket because the pistons are just a little bit down at top dead center, so I don't throw a head gasket on there. But if I cut through the middle of that and cut through the middle of that, I can take my calipers and measure and see what I got on both radial clearance and depth clearance. So I'll do that now and note that, and then I'm going to be busy for probably the next 45-50 minutes. I want to get the rest of these pistons in and the rod bolts torqued. Okay, our short blocks together. These are custom Racetech pistons, forged. 11cc dish, Coy's timing set, billet steel gears, double roller set. I'm going to roll the engine over so you can see the rods. And here's the bottom end, that scat crank, and you can see the bottom of the pistons. Molnar rods. Stout bottom end. This thing will look period correct on the outside, but it'll be bulletproof and modern on the inside. Alright, so this is my pre-oil pan checklist here. Cut out around the bolts on the gasket. I went through and double checked all my fasteners, retorqued them, even the pickup bolts, and checked pickup clearance, and we are approved for takeoff. So we're going to clean the oil pan. It's just a stock appearing oil pan from Scott Drake. So we're going to end up with 5 quarts in the pan and 1 in the filter, and we'll get that pan bolted on. Okay, so here's where we are. I had to take the oil pan back off because there's a little baffle that sticks up about midway to the rear of the pan that a rod bolt was hitting. So got that taken care of. The heads are bolted on nice and tight. Part pointers on, had to adjust it and grind just a little bit off the side so that it points at 0 at top dead center. Got our morale lifters in here. I had gotten ahead of myself weeks ago and painted the timing cover, but that's no problem. I can just lay paint over top of it. And the next step is to throw some paint on this thing. That's how they did it back in the day, just all one continuous paint job. So that's how I'm gonna do it. I'm gonna mask everything off, put some old valve covers on here, and mask the lifter valley off and the head flanges and everything. And we're gonna lay some primer down, lay some paint down, and we're gonna be good to go. Okay, so we're getting ready. We're pretty close to putting the intake on. And what I like to do right before I do that is I go through and just overlook everything, give everything a double check, and prime the oil pump, because this is your last chance to correct any oil flow issues before the intake goes on. And you know, it's not that critical on a hydraulic roller motor, but on some of the solid roller stuff, if you use like a Crower lifter or some of the other brands, the oil feed hole needs to be connected so that it will pass enough oil. And you know, I've also found, I guess, instances with hydraulic lifters where the metering disc was left out of the lifter body, and it just shot all kinds of oil all over the place. So you know, this is just your last chance to double check everything. And I've got oil pressure gauge and a 1/2-inch drill, and it's easy just to give it some gas here and see what the oil pressure does and see what the lifters do. Alright, so we got up to 70 psi there. This is 1030 oil, and this is a M57B pump, and we're in good shape. So next step is the intake will go on. So here's if you remember we've already looked at the intake manifold several videos back and checked out the angles and checked out what gasket and everything that we needed for correct fitment. And I'm going with these 30 thousandths thick gaskets from SCE, and they make everything sit nice and pretty. The intake is flat and square like most Blue Thunder products are. I've already got my gaskets glued to the heads, and then I'm going to put just a paint layer thin that just come out wrong, I guess. A very thin layer of silicone on top of the gaskets as well. Then I'll lay my beads for my china walls, and then we'll get some bolts in it and get it cinched down. So we're getting pretty close to a finished engine. Once the intake goes on, I can put the water pump on and the water pump pulley, the alternator. Trend had a little faux pas on sending push rods. I ordered a large quantity of push rods at a time for several engines, and they left a couple of one particular size out that I need, and those are on the way. But we are just very close to taking this thing to the dyno. Okay, intake going on. Well, this is pretty much where we're going to end for this week. I'm waiting on push rods and my valve cover breathers to come in, and my thermostat housing water neck to come in. I had began to put the alternator on, but then remembered that this customer has an ERA Cobra, and they supply their own alternator brackets. So I threw the alternator back in the box, and I'll ship that along with the engine. But this is it. It's a good looking motor. So hopefully in the next probably 2 weeks, I'll get this thing on the dyno, and we'll be able to see what it does. All right, I know this was kind of not a very detailed video. We were kind of just thumping through it, but I am trying to get some engines done, and don't really have the time to sit down with every detail. That may come later on, but I appreciate you still tuning in and watching, and stay tuned. We got a lot more FEs to put through the pipe, so hit that subscribe button so you won't miss anything, and hit that thumbs up button. All right, guys, have a good weekend.